Hello everyone. On today's session we'll see Unit 1 microwave tubes. The topic is helix traveling wave tube. The topic is slow wave structures. Slow wave structures are special circuits that are used in microwave tubes to reduce the wave velocity in a certain direction so that electron beam and signal can interact. And from the previous knowledge, we know that the relation between the gain and bandwidth. If bandwidth is high, gain is less. If bandwidth is more, gain is less. If the bandwidth is low, gain will be more. If a narrow band, gain will be more. So gain and bandwidth both are having the inverse relation. But here we are trying for high gain over a wide bandwidth. For that, non-resonating or slow wave structures are designed for producing a large gain over a wide bandwidth. So that is what the advantage of the slow wave structures which are used in the microwave tubes. So slow wave structures are special circuits that are used in microwave tubes to reduce the wave velocity. Here wave velocity means velocity modulation, to reduce the velocity in a certain direction so that electron beam can interact with the signal, and due to the energy transfer between the electron and signal, then there is a improvement of signal strength. I'll explain in the next slide. And slow wave structures follows the property of periodicity in the axial direction. And these are the several types of the slow wave structures. So helical type, or you can call helical line, folded back line, zigzag line, integrated line, corrugated line, and coaxial line. So these are the some of the slow wave structures. Coming to the next topic, helix traveling wave tube. The traveling wave tubes used for high power microwave amplifier designs. And there are two types of traveling wave tubes. The first one is low power traveling wave tube, and the second one is high power traveling wave tube. Particularly, low power traveling wave tubes designed for the receivers. So these are high sensitive, low noise, wide band amplifiers. Mostly used these type of traveling wave tubes. I mean low power traveling wave tubes in the radar receiver equipment. Coming to the next type, high power traveling wave tube. Those are designed for the transmitters, and these are mainly used as a pre-amplifier for the high power transmitters. Let's see the construction of the helix traveling wave tube. The construction of the helix traveling wave tube split into 8 major elements. The first one is electron gun, second one is RF input, third one is magnets, fourth one is attenuator, fifth one is helix coil, sixth one is RF output, radio frequency output, seventh one is vacuum tube, eighth one is collector. So these are the 8 major elements in the helix traveling wave tube construction. Let's see the detailed diagram of the helix traveling wave tube. It contains gun supply and slow wave structure. So part 1, gun supply, and second main elements, main part is slow wave structure. See here, helical type of line or helix line used as a slow wave structure, okay, and which is focused by the 2 magnets, and exactly at center of the helix there is an attenuator. Coming to the other side, there is a heater with a combination of anode and a cathode, which is connected to the regulated power supply. By applying the beam voltage, energize the heater with a combination of cathode, generates the electron beam and that electron beam is used to travel from cathode to anode side, and finally it is entered into the helix slow wave structure. And there are two inputs here. One is uh, I mean electron beam, which was generated by this heater and cathode, and other side there is a radio frequency input. Here you have to apply the radio frequency input to the helix traveling wave structure. Then both are traveling through this uh, slow wave structure, and which was focused by the magnets. And other side there is a collector which is used to collect the electrons, and that is connected to the collector power supply. Okay, so this is what the detailed diagram of the helix traveling wave tube. Let's see the simplified version. The simplified version quite easy compared to the previous one. So the simplified version, as I said earlier, there is a two parts. One is a gun supply and other one is slow wave structure or helix. Check it here. Gun supply generates the electron beam, and that electron beam is entered into the slow wave structure, and other side there is a RF input to the helix. When the signal is traveling through the helix or loops of the or turns of the helix, it generates the electric field, and electron beam and RF input combinedly travel through the axis of the helix. When it goes through or when it travels through the axis of the helix, when it reaches to the exactly at center of the helix, as from the previous detailed diagram we know, at center there is a attenuator, and attenuator slows down the electron beam and at the same time reduces the signal strength to 0. If that is the case, the electron beam and whatever we are applying the RF input, and both are traveling right, so electric field and at the same time electron beam, both are interact at the center of the helix. Due to that interaction, there will be a velocity modulation, means electrons give up their energy to the field. Due to that, so other side there is a amplified version of the signal generated, I mean new field generated with a high signal strength, so that you see at the RF output. And electrons slow down right due to the attenuator, and those electrons collected by the collector. So this is what the operation of the helix traveling wave tube. Instead of using the helix, you can use some other lines, some other slow wave structures also, whatever we have discussed so far. Types of slow wave structures, you can use the folded back line, zigzag line, integrated line, corrugated, coaxial. But here particularly we have taken the helix line as a slow wave structure, and it be acting like a delay line. Okay, when the field whatever we are applying input which is traveling through the turns of the helix, it generates a field. Other side electron beam generated by the heater, and both are traveling through the axis. When it reaches to the exact lead center, there be attenuator, it slow downs the field as well as the electron beam, both are interacted here. Due to that interaction, electrons give up their energy to the field. Due to that, new field will be generated with a amplification, I mean amplification process. So the signal strength will be more, and the slow down electrons, because they are giving their energy to the field, right? So electrons become slow down, and those electrons collected by the collector. See here velocity modulation, you see the diagram, then you will come to know how the field is improved here. So the electromagnetic field produced by the helix causes electrons to speed up and slow down, and this produces a velocity modulation of the beam, which produce density modulation. Okay, so due to the velocity modulation, electrons become like a bunches, group of electrons. So here particularly electrons give up their energy to the field, so they become like a group, slow downs and become like a group, and those was electrons are collected by the collector. So this is how the velocity modulation performs in the traveling wave tubes. Let's see the amplification process. As I said earlier, the electrons enter into the helix at a zero field, not affected by the signal. Those electrons enter into the helix at a accelerating field, those we can call as a accelerated. The electrons entering into the helix at a retarded field, those are the decelerated. Acceleration, deceleration, no change. Electrons enter into the helix at a zero field, not affected by the signal. Electrons enter into the helix at a acceleration field or acceleration field. So those we can call like a accelerated electrons or accelerated give speed up. Accelerate, I mean helix electrons enter into the helix with a retarded field. So those will be deceleration. Acceleration, deceleration means simply when you are applying the RF input. Yeah, see here RF input. So it's we suppose consider like a sinusoidal. The signal contains a positive half cycle and negative half cycle, right? Electron meet up with the positive half cycle, those are the accelerated electrons. Electrons interacted with the negative half cycle of the sine wave, those are the decelerated electrons because they give up their energy, right? Okay, some of the electrons gains the energy, you can consider as a accelerated electrons, and the electrons which are interacted with the negative half cycle of the sinusoidal. Suppose I have considered here the sinusoidal as a RF input. So negative half cycle, then the electrons give up their energy, right? So these we consider as a deceleration electrons. And some of the electrons, they doesn't give up their energy, or that doesn't gains the energy from the field. So those maintains the constant velocity, so not affected by the input. See the diagram here, check it here. So the blue line shows like an electron beam, and this orange sinusoidal signal, this is what we are applying to the we are applying as the input. So both are traveling along the axis, but when it reaches to exactly at center, okay, both becomes like a zero, means here there is a attenuator in the structure. So due to the attenuator, electron beam becomes like a slow down. At the same time, strength of the signal becomes like a weak, it's make it down to zero. Both are interacted here. Here electrons in the beam give up their energy to the field. Due to that, there is a new field will be generated with a high signal strength. So this is how the amplification process will be done in the helix traveling wave tube. This is what the physical construction of the traveling wave tube. We know that one side there is an electron gun, other side is slow wave structures. Okay, so this is what here I have taken the helical as a slow wave structure. Okay, we are applying the RF input and taking the RF output. In exactly at center there is a attenuator. Okay, as I shown in the blocks, same thing. Okay, I am representing here, and there are two coupling resonators. Other side there will be a collector to collect the electrons. So this is how electron beam will be happen. This is how the bunching process, how the electron beam become like a making be like a group bunches. So finally you have to remember one thing, bunching would occur through the effect of velocity modulation, point number one, and the velocity modulation would be caused by the interaction between the traveling wave field and the electron beam. That is the second important point. Due to the bunching would causes electron give up their energy to the traveling wave, so that field were corrected polarity and slow downs the bunches, and the energy from the bunches would increase the amplitude of the traveling wave in a progress action that would take place all along through the length of the traveling wave tube. So how the bunching is happening, and what is the velocity modulation, and what is the effect of the velocity modulation, and due to the velocity modulation how this strength of the or amplitude of the traveling wave increasing. So these are the three important points you have to remember. So that is what the exact operation of the traveling wave tube. Bunching would cause us through the velocity modulation, and velocity modulation would caused by the interaction of the traveling wave and electron beam. So due to that, so due to the bunching, electrons give up their energy to the traveling wave, and due to that, so energy from the bunches would increase the amplitude of the traveling wave. Okay, that's how the amplification process will be happening. Okay, so this is what the diagrammatic representation of the amplification process, how the signal is amplified due to the velocity modulation and bunching of the electrons. Let's see the characteristics of the traveling wave tube. The first characteristics of the traveling wave tube is the traveling wave tube is a high gain, low noise, wide bandwidth microwave amplifier. High gain, low noise, wide bandwidth microwave amplifier. The second one is it is having the capable of gains greater than 40 dB. And third one, traveling wave tube have been designed for frequencies as low as 300 megahertz, as high as 50 gigahertz. It can be operated in between 300, as low as 300 megahertz and as high as 50 gigahertz. And initially traveling wave tube is used to be like a voltage amplifier, but due to the wideband and low noise characteristic, nowadays it is using like a RF amplifier in a microwave equipment. And next one is it is capable of developing a powers up to 2.5 kilowatt. It is having a capable of developing a powers up to 2 kilowatt. And at last efficiency of the traveling wave tube is up to 20 to 40% is possible. So these are the main characteristics of the traveling wave tube. The first one, high gain, low noise, wide bandwidth microwave amplifier. And second one, having a capable of gains greater than 40 dB. Third one, the frequencies as low as 300 megahertz, as high as 50 gigahertz. And initially it is used as a voltage amplifier, but due to the wideband and low noise characteristics, it is be using like a RF amplifier in the microwave equipment. And next one, it is having the capable of developing the powers up to 2 kilowatt, and the efficiency of the traveling wave tube, that is 20 to 40% is possible. Coming to the specification, the first specification is a frequency range, that is 3 gigahertz and higher, bandwidth about 0.8 gigahertz, and efficiency 20 to 40%. Power output up to 10 kilowatt average, and power gain up to 60 dB. Compared to the comparison of the traveling wave tube and klystron, so both klystron amplifier and traveling wave tube both are linear type, or you can call O type devices. And coming to the klystron, these are the resonant cavities. Resonant cavities are used in the klystron amplifier. But coming to traveling wave tube, non-resonant type cavities are used here. Non-resonant wave circuits are used in the traveling wave tube. And klystron amplifier is a narrow band device. Coming to the traveling wave tube amplifier, it is a wide band device. Let's see the application. So the applications of the traveling wave tubes are mostly used in the microwave receivers. And second application is the satellite communication. And third one is a troposcatter links, and mostly used in the airborne and shipborne power radars. So these are the four main applications. The first one used in the microwave receivers. Second one used in the satellite communications. Third one used in a troposcatter links. Fourth one airborne and shipborne high power radars. So these are the some of the applications of the traveling wave tube. And this is what the session. And next session we'll see the two cavity klystron amplifier and reflex klystron operation. Thank you so much.